Hello and welcome to another one of my mad science experiments again. Today I'm going to incinerate another hot dog again by literally electrocuting it. But unlike that hot dog disintegrating video I made over a year ago, today I'm actually going to try something different. I'm going to actually try to make the hot dog sing while I try to electrocute it. Now for most of you out there are probably wondering, okay, what do I mean by making the hot dog sing? Well, I did a electric arc video with the flyback transformer, and somebody had posted on the comments about, hey, do you want to build a singing arc? And I was thinking about it for a second, and then I looked at other videos on YouTube about what other people were doing, and I thought for a second, like, everybody else is doing that, so I got this idea that why don't I try something different here? Anyways, if you ever remember my hot dog disintegrating video over a year ago, one of the things you'll probably notice is you could actually hear the electrical noise coming out of the hot dog while it was being electrocuted. Anyways, I thought for a second, like, you know what? Is there some way I could replace that with an audio signal and actually play music or sound out of it while I was electrocuting it or disintegrating it? Anyways, a singing arc plus the idea of that pretty much led to this interesting experiment. So before we get started, I'd like to show you all the different components here that make this whole thing work. Okay, the first thing we have here is the step-up transformer. This is actually a ballast from a metal halide light which is used in gymnasiums. I use this to step up the voltage with. I have 120 volts coming in, and it comes out as about 280 to 290 volts on the secondary. And over here we have the rectifier unit, which is used to convert the alternating current into direct current. And over here we have a bank of capacitors, which is used to filter out any ripple noise from the AC current coming in so we can get a nice smooth direct current output. One of the reasons why I'm using so many capacitors here is because I want to make sure that we filter out as much AC noise as possible, so when we're electrocuting our hot dog all we hear is music and not electrical noise. And since we'll be getting the peak voltage from the AC waveform, we should be getting roughly around 380 to 385 volts. And over here we have a set of CM600 IGBT power brick. The one on the right is used to actually control the power with. The one on the left I'm just using as a damper diode to reduce inductive kickback. And over here we have the actual driver unit. This is actually what drives the IGBT brick. This is a pulse width modulator. It takes the audio signal from my iPod and converts it into a pulse width modulated signal, which then is ran through a MOSFET driver, and then which travels through those two blue wires to the IGBT. Okay, now over here I have the negative electrode is connected to that metal plate in which our condemned hot dog is sitting on top of. For the positive electrode, which will be connected to the top, I'm actually going to use that hammer over there. I'm going to apply the hammer off to the side there, basically sandwiching the hot dog between the side of the hammer and the metal plate in which the hot dog is sitting on. This way I can make adjustments so to make good electrical contact with the hot dog. Oh, in case you're wondering about the song I'm going to play while I electrocute the hot dog, the song I'm planning on using is done by a band called Dope. I edited the song so that the chorus line would keep on looping over and over. So without further delay, let's get this show on the road.
was turning.